So for the integrated back sensor, there are a number of very important, equally important components. To begin with, the substrate, as we call it, which is barely visible on this dummy, which is two components, a adhesive combined with a hyper stretchable film. That's what we call the substrate. On the substrate are all the other elements are integrated on the substrate. The other elements are the stretch sensors, which are the golden lines here, which is actually a polymer stretch sensor. It's all very, very, very thin. It's 30 micrometers thick, and it can be stretched up to 100% for endless life. Other components integrated on the substrate are printed batteries, which are the black dots here. The wireless data transfer, which is represented by this little spiral. And the other spiral, which is identically the same, but this is a dummy, is a representation for wireless charging. And in the middle, you've got an NXP chip, where we do all data processing, pre-processing, scrambling, and energy management, etc., etc.
And Bluetooth?
Yeah, well, Bluetooth or Zigbee or MC or whatever. Anything for a customer. Actually, this is only an in-between stage, because the chip itself will be only a quarter of the surface and 0.3 millimeters thick. So just a little flinch.
So everything is printed except the chip?
Yeah.
All right, and exactly the same here?
Yeah, it's 4 modules, as a matter of fact.
And all 4 would communicate with a box somewhere in a pocket or somewhere?
In this application, for instance, you have multiple possibilities. One of the applications is that it is used as a feedback system for neurostimulation therapy. And there you are going to communicate all the information to the therapy system itself for firing electromagnetic pulses to electrodes, which are then implanted into the spine. Yeah. No, but the medical companies we are talking to are very, very interested, because today the technology works perfect. It can save people with very, very, very heavy back pains, but the effect of neurostimulation dies away after some years. There is only one way to extend the efficacy of the treatment, and that is by dosing the pulsing per zone. But for that, you need to know where the back is, exactly at what position, etc., etc.
Okay, so this is going to be somebody really, really qualified who's got to perform a procedure like that.
That's our B2B customer.
Okay.
We will be part of the development of a complete system.
Do you do many different things?
Yeah, well, like the one over there. Yeah, maybe I can put it back here.
Okay.
Yeah,
it's okay. So what is that one?
Well, for instance, here we show the sensitivity of a small version of the sensor on the finger, and we can even measure, for instance, somebody trying to hold his finger still, which has never been done before. So we can measure that, because a living person cannot keep his finger still. Only a dead person can keep his finger still. And we can measure that. And why is that important? For instance, one of the applications of this would be making a musical instrument from your hand. This body motion music. And why is that important, that it's so accurate? Because we've talked to a number of composers, present-day composers, of course, and they are all about accuracy, precision, as they call it, because that's what music instruments are all about, precision. And actually, in the present day situation of making music electronically with gestures, is now with sort of a clunky devices, sort of mittens, loaded with heavy, stiff sensors which don't do the job. They're not satisfied with that. With this, we would even have to lower the responsiveness of the system because it's too much.
So how about a pianist could wear gloves to expand all the other instruments through the fingers? And
yeah,
stuff?
you could do that. Yeah. I mean, air guitar is never going to be the same.
Where are you from? The company?
Belgium.
Belgium. All right. Cool. Is lots of your technology already in the market, or is it starting?
Well, like I said, we are B2B, so we develop. What we do is we reach out to a big company, and we lay down a value proposition, which we ourselves have identified, because it's too much asked to throw all this technology and all this possibility with the printed batteries and the sensors and the algorithms. You cannot throw that at somebody and say, think about this and come back with something. We turn around the rules. We just look at the big company, we look what they do in a certain market segment, and then we say it could be 10 times better or more performing or whatever, or more attractive or sexier, or etc. And we walk towards that party and we lay down exactly the product suggestion that we would do to them. And that's what we are doing at the moment. So we have a number of contacts going, and that would result in a first contract, hopefully.
So you started by doing printed electronics?
Printed electronics is one of our specialties, and what we actually do with our group of 4 is making a constellation of world-class players in our network. That's what we do. So we make a lineup of specialists of world-class. For instance, the chips are from NXP. That's the number 3 chip manufacturer in the world. And they actively support us. So whenever we would have a contract to really work out one of the value propositions that we now showed to all these parties, we already have this potential lineup of world-class players to make it happen. And then it will all come together. That's the idea.
So we're here at Wearable Technology Europe in Berlin, and I'm here with a new wearable technology exhibitor, Bainisha, and I'd like to introduce you to Patrick van der Weyer.
Hi.
So Patrick, tell us about your company and products. Tell us about what you do.
Well, actually, we are a B2B company, so our products is what our customer want them to be. Actually, we have been working on a number of these concepts, as we call it, and one of the most astonishing concepts is the one over here, which is a completely integrated back sensor that has a number of very, very important aspects to it. The most important one for medical applications is because it's on skin, it provides an absolute body reference frame, which is quite important for medical applications. 2 other very important points are the hyper accuracy, it's 0.3% of the displacement, and the very, very high sampling rate. We go to 1,000 hertz, which is quite fast, 100 times faster than is required for human applications. But anyway, we can come down from that. That's the main issue, as a matter of fact.
So how would you say your products are helping wearable technology move forward?
Well, we are actually in a specific niche of wearable technologies. First place, we're on body, which is a specific family of wearable technology. And moreover, I would even call it an invisible wearable technology. Again, also some sort of subfamily. Why invisible? Because, as you can see here, because it's on skin, you necessarily need to wear clothes afterwards. I mean, unless you go bathing, stuff like that. But invisible because it is on skin and because you can wear your clothes over it.
So the issue about water resistance, is that made it a challenge, or
Can you?
the issue you mentioned about as long as you don't go bathing? So
No. That's not an issue. I mean, what I'm saying, it's an invisible wearable technology. As long as you not go bathing, I mean, then it becomes visible, of course, as you can see here. That's what I'm saying.
Okay, excellent. And so, what are the opportunities, do you think, in the wearable technology market for this? You mentioned the healthcare sector. That's a big area for you. Any other opportunities you're seeing?
Well, we are talking to a lot of parties at the moment, and an important number of these parties are in top sports, so professional sports. There you need a higher level of body motion capturing than you would usually need in a consumer market, where you rather talk about charts and approximate results and indicative measurements and stuff like that. This is much more for high-level measurements, for really getting that last extra hundredths of a second from a top athlete in some sort of discipline, be it a tennis player or a volleyball player or whatever other sports. Everywhere, any sports where body motion capturing and the advancement you can expect as a professional sportsman has any relevance at all. So that's a lot of sports, of course.
And this is your first time at Wearable Technology Europe. How have you found it?
Overwhelming, yeah. we are, as a matter of fact, stampeded a little bit. So, but that's okay. That's a good thing.
Nice problem to have.
Yeah, absolutely.